Merhabalar. Hi. We have been examining passive filters. We have already seen transfer function, which is the critical part of the filter analysis and synthesis. Filter classification we have seen, low pass filters we have seen. Now in this video we will be examining high pass filters. What we are going to see inside. We are seeing this is written wrong, that should have been high pass. We're going to see that high pass filters can be constructed on low pass filters. What happens when we load the filters, we will be examining. Border diagram, this is a terminology already been used in circuit theory. Now we don't use that, we use Protos and frequency response analysis. High pass filters as an outline here, and that is a Protos result for this high pass filter. Let's examine all this in detail. We've got to move open board now. Here we are. Let me clear this area first. You see here that was the high pass filter here. Sorry, that was a low pass filter. So this I'm going to correct that. This is not low high pass. This is going to be high pass. In the low pass filter, if you take the output from the capacitor, it becomes low pass. If you take it from the resistor, it becomes high pass. Why is that? When this is 0, that becomes a maximum, isn't it? Because that, if you write KVL equation for this loop, this is minimal voltage here, maximum voltage here. If it is low pass, whatever happens is 0, that's going to be maximum here. So the opposite of the low pass is the high pass. So if you find the transfer function, if we take the output transfer function Hs was 1 over Rc over S plus 1 over Rc. It was this. Now it became this. So I have find out this transfer function step by step for the low pass filter, so you can find that transfer function for this high pass filter your own. And then you're going to, as I done it for the low pass filter, you could find the cutoff frequency as this. Step by step I examined it in low pass, so I left it for you to do it your own in here. So this is cutoff frequency, that means that is the highest value is 1. So cutoff frequency, the amplitude is going to be 1 over square root of the, so that is 0.7.7. And if it is low pass filter, or whether it is low pass filter or high pass filter, this cutoff frequency do not change. What it means, so if you draw the low pass filter characteristic, it's going to be like that. So both of them pass through this cutoff frequency. That could happen now. If you come, so that is one of the simplest high pass filter examples. The other one is this one. it is a serially connected and a resistor and a capacitor, a inductor. If you take the output from the inductor, you get that transfer function. If you take it from the resistor, so instead of that S, you're going to get R over L. So cutoff frequency for this one is also equal R over L. So same as the low pass filter cutoff frequency. So for low pass it was like that. When it became high pass, it became this one. So you could see here low pass frequency, low frequencies is not observed, in general not observed at the output. What high frequencies, these frequencies, you can see the input signal exactly at the output, so it is a high pass filter. So the next step here tells us what happens if you load this circuit, if you load the filter. So that's the filter that we are talking about, high pass filter. So we are loading it because when you filter a signal, the output signal is going to be used somewhere. That is what somewhere is. So when you connect that R, so that means you are changing your circuit, isn't it? So you've got to examine now the output where the RL is included. So your transfer function is going to change. When your transfer function is changed, your cutoff frequency is going to change, or your function is going to change. Therefore, so characteristic is changing. That might be something that you don't want to see because the characteristic is changing. Unloaded when loaded case. So this is the unloaded case and that's the loaded case. Therefore, a new problem injected here. So how to solve that problem? We need we need some solutions, but I'm not going to say those solutions here. What they are, I don't say it here. The next slide here, maybe I write it once again. Body diagram. We were using the body diagrams when we don't have these simulation programs. When that simulation programs case in, such as Proteus, Cadence is another simulation program. When these simulation programs are introduced, our filters characteristic equations, which is the transfer function module change with respect to frequency and transfer function angle change with respect to frequency, are called body diagrams. In simulation programs, we call these diagrams as frequency response. So when we don't have these simulation programs, we were using the body diagrams. So there were some rules how to draw the body diagrams. Just mention to you to know that what body diagram term is. So in the simulation program, response, frequency response is the same as body diagram. Or you might say the body diagram is the filter characteristics of the circuits, related circuits. So there is another slide here that is the output of a Proteus example. The same circuit we've got here, a capacitor and a resistor, and cutoff frequency is 10,000, but this is angular frequency. If you transfer it hertz, it's 16 hertz. So that means the cutoff frequency here is 16 hertz. It's going to be somewhere here. So if you put the probe here, so this diagram directly gives you the border diagram. Simulation program gives you border diagram. This border diagram at the same time is the filter characteristic. What is filter characteristics? That is the transfer function. So 20 times log 10 h j omega module is this green one here. The red one here is the angle change. Angle is theta, is the angle of h j omega. A change of this with respect to frequency. So that is the red one. That one is the red one. Now I can make it red color, of course. So red one is this one. And I make this one is green as well. Huh? So that's green one. That's the red one. So why we call it filter characteristic? You could see that which frequencies are going to be seen at the output, which are not going to see. So if you go in details, it's going to be somewhere here, 3 dB. After the 3 dB, so all these frequencies are passing through. These are not passing through that easy. So that's a high pass filter. So you don't have to do it by hand or manually to find all these functions changes. Use the Proto simulation program. You can directly see it. If you choose here it says frequency response. So you're going to put the probe here and you're going to choose frequency response. So I just remind you, this axis here is decibel. So that is the decibel. And this axis here is F, not G, not omega. So what is the relation between those two? As you know it, 2pf, that's the frequency, unit is hertz, and this is an angular frequency, and unit is radius over s, over second. So that is the high pass filters video. That's the end of it.